So far we focused on constructing triangles using three measures of angles, but now let's switch our attention to constructing triangles based on measures of the sides. Let's say this is our task. We need to construct a triangle with side lengths of 3 inches, 4 inches, and 5 inches. So let's take our ruler and we'll measure off those three lengths, 3 inches, 4 inches, and 5 inches. Now we need to take those and combine them to make a triangle. So we do that, and this is our result. When students compare their work, they will see that, hey, we all have the same triangle. So the result will be that this does result in a unique triangle. Every single student will have a triangle that's exactly the same as everyone else's. Something to pay attention to here, notice that no sides are of equal length. So if we use side length as our criteria, this is a scaling triangle. Just out of curiosity, let's use our protractor. One of those looks like a right angle. And when we measure it, sure enough, it is 90 degrees. So the angle that we measured is 90 degrees. So if we use angle measure as the criteria, then this is a right triangle, in addition to being scaling based on the lengths of the sides. Let's take this task. Construct a triangle with side lengths of 3 inches, 4 inches, and 8 inches. So we measured off those three lengths. Now let's use our length of 8 inches and let's form our triangle. Oops, wait a minute. This isn't working. We can't make a triangle out of these three given lengths, so no triangle is possible. With repeated examples of this type, students should discover that the sum of the lengths of the two shorter sides of a triangle have to be greater than the length of the longest side. So here the two shortest sides, 3 and 4, that's a sum of 7, which is shorter than our length of 8 for the longer segment. So this wasn't possible because, again, the sum of the two shorter sides of the triangle have got to be longer than the longest side. Let's take on this task of constructing a triangle with side lengths of 4 inches, 4 inches, and 6 inches. Okay, so when students do that, this is what we come up with. When students compare, they'll find out that, hey, this is a unique triangle. We all came up with exactly the same thing. In this case, we had two sides that were of equal length. If we use side length as a criteria, then this is an isosceles triangle. Again, because we had two sides being of equal length. Just out of curiosity, one of those angles looks like it's more than 90 degrees. So let's measure it. Yep, it looks like it's 98. One of the angles is an obtuse angle. So if we use angle measure as a criteria, then this is an obtuse triangle. I wonder what the other angles have for their measures. Well, let's see. If I measure this one, that's 41 degrees. If we switch over to the other one, we have to use our supplement though. Yep, that's 41 degrees also. Letting students do some discovery and some work on their own, they should be able to figure out that when you have an isosceles triangle, you can have two angles of equal measure as well as two sides of equal length. Let's do this task. Construct a triangle with all three side lengths of 5 inches. So we have our three equal lengths of 5 each. Put them together, and again, students are going to come up with a unique triangle. In this case, again, all the students are going to get the exact same thing. What we have here are triangles that have all three sides being equal lengths. If we use side length as a criteria, then this is an equilateral triangle. Okay, we're curious again about the angle measures. Well, let's see. Let's measure the angle on the rightmost side. Well, let's see. We have to use our supplement again. 120 degrees, the supplement is 60, so that one is 60 degrees. Let's measure this one. It's an easier task. This one is 60 degrees. Let's measure the top one. That one is 60 degrees. Interesting. This time, all of our angles are acute angles. If we use angle measure as a criteria, then this is an acute triangle. Now, all the angle measures were equal. So using angle measure as a criteria, then this is also an equal angular triangle. So now students have constructed triangles based on information regarding side lengths. Results included scalene, isosceles, and equilateral triangles. Students should also note that when only given information about side lengths, the constructed triangles were congruent, despite the fact that no information was given about the angles. Another interesting tidbit, if we do things right, students should discover that the sum of the lengths of the two shorter sides of the triangle have to be greater than the length of the longest side. The standard really doesn't specifically address this, but we've already seen that there seems to be some relationships between the angles and the sides. Remember, we had this triangle, we had this task, we were given angle measures of 34, 71, and 75. Well, let's measure the lengths of the sides. That appears to be 4. This one appears to be a little less than 7, about 6 and 7/8. And this one looks to be about 7. Let's see what kind of relationship there might be if we look at the angles and the sides together. If we look at the smallest angle, 34 degrees, notice the measure of the opposite side is 4, which is the shortest of the 3 side lengths. The 75-degree angle was the largest angle, and notice that 7 is the longest side that's opposite of it. If we look at our 71-degree angle, that was the in-between angle measure, and notice that the 6 and 7/8 side length lies in between the 4 and the 7. If students do this over and over, they should reach the conclusion that in the same given triangle, the larger the angle, the longer the opposite side is going to be. Is there anything else? Well, let's do some more digging. Let's take the example that we did where we were given 2 equal side lengths, 4 and 4, and then also the 6. And we measured the angles to be 98, 41, and 41. Well, look, 98 is the biggest angle, and the side opposite of it is the longest side. Well, the other two, 41 degrees, are equal angles, and notice that, the sides are equal, the ones opposite them. Then we had that equilateral triangle where all the sides were 5, and we measured the angles to all be 60, and notice what happens here. Given some experience, the students here should be able to determine that in the same given triangle, angles with equal measures will have opposite sides that are equal lengths. So with regard to triangles, there's a lot of facts and definitions that are not specifically addressed in the standards. This standard, 7.G.A.2, should be used as the foundation to introduce and teach all of these important items regarding triangles. So this is a very important foundational standard. Again, there's a lot of things that it doesn't specifically mention, but this is a good time to really address a lot of those other terms and other facts. Again, there's a lot of things that happen here. There's some things that happen with constructing the triangles based on the measures of the angles. It seemed like a lot of times that resulted with triangles that were similar, as opposed to when we were given the task of constructing triangles given the lengths of the sides, students came up with the same triangles, so they seemed to come up with congruent triangles. So again, all kinds of little patterns like that, all kinds of facts and relationships that should be addressed at this point. If we look at the standards for mathematical practice, by addressing some of the issues and doing some of the activities in this standard, students would reason abstractly and quantitatively. They would construct viable arguments and critique the reasoning of others. Yes, in this standard, there's a lot of opportunity for discovery and for discussion. And if we look at the remaining standards of mathematical practice, students would use appropriate tools strategically, like your protractors especially. They would attend to precision. They would look for and make use of structure, and they would definitely look for and express regularity in repeated reasoning.